Hello. I just want to go over another function um, to add to this tree system that I created earlier. Uh, this was a problem that I came across on leetcode, and it was to sorry, not traverse, to invert the way the nodes were in the tree. So, um, so for example, if we had 10, 5, and 20. Keep the same root node and just swap um, just like this, and then do that along the tree. So um, if this one had like 15 and 30, it would be 10, uh, 20, 5, 30, and 15. That's a 30 right there, 20, 10, 25, 30, 15. So just swap them as we go. All right. So before we start, I just want to go over this. I'm not gonna lie, I used ChatGPT for this. I just wanted it to print out the way I just showed you right here, on the console, so it's better for y'all to understand it. I don't really know what exactly or how it does it, um, but I'll look into that later if you want to copy the code or something. Here it is, and you have to include these two headers for it to work. Um, as well as that, I changed the print method from the last video to print in order. So it's just going to print at 10 if it was 10, 20, 30, 40, sorry, 30, 40, 50. So if these nodes were in a tree, like I just showed you, it would print it like this. Um, and the invert that I'm going to do is we'll be able to print it out as 40, 30, 20, 10 as well. Um, when we create it. And then yeah, so let's get to it. Um, we're going to start off with a void function, and it's going to be called invert. And we're going to pass in a tree node. We're just going to pass in the root. Uh, base case is always with similar to all of these if node is equal to null, return immediately. Um, and now we get into the swapping part. It's going to involve recursion, just like a bunch of these other functions that we've created. So here we're going to create a tree node, um, a temporary variable to hold our left side of the node. Uh, so just as for a quick example, if we have this, this is a 5, this is a 15. So 10, 5, and 15. Um, temp E is going to hold node, so our current node dot left, which is 5, right? So now, um, sorry, I did not mean to do that. So now, um, node dot left, the current node, which is 10, left is empty. It's not being occupied right now. Then we do node left is equal to node right. So then we take the right side, which is 15, and then just pass it on to the left side. Um, so then 15 is now on this side. 5 is still in the temp. And then we say node right is equal to temp because temp is currently holding what our left value is. So node right is equal to 5. And yep, and then we would recursively call this to both the left side first and then the right side. So we would say invert um, node left, invert node right. So what is happening here is if we have, for example, more nodes, or let me finish this real quick before I go into what exactly is happening. And here in this public side, we're gonna say void um invert. We don't have to pass anything into it. And then we just call the private function in here. And then we just pass root into this one. So let me run this real quick. Um, Here we go. This is what I was telling you about how it prints it out as a tree. Let me do um, just a little message real quick. Print or in order. Let's just call it printing in order. Printing order. And then we just call tree dot print, not print tree. Sorry, print in order. Um, so let me run that and uh-oh. Sorry, I'm calling this all wrong like this. Let me comment this out for now. Oh shoot. Okay. Oh, here we go. So as you can see here is the tree node. So we have 10 as our root node, 5 in the left, 5, 30 here, 20 here, 40 here. Um, After 40 we have 60, 50, and 70. So this is what this is doing here. And as you can see, the printed order is just doing it from least to greatest. Um, okay, so now back to the invert function. So what this is doing is um, we're going to recursively call the left side first for moving and swapping the elements on the right side. So in this case, we have the uh, 10 root node. 10 will always be the root node. And from here, we would um, swap the left and the right side. But in this swap, um, all of the nodes below 30 would remain um, once we swap it. So 60, 70. So this is in our first iteration loop, in our first recursive call. After this, it would then recursively call on this node, so 30 left, 20, and then swap the left and the right before moving down the left side. But in this case, we have a null. Once we reach null, like we said in the code, return. So it returns back to 30 and then recursively checks the right side. And uh, as you can see right here, it checks the right side and then it enters back into this part right here. So once it returns back to 30, it comes here, swaps the left and the right part of um, um, 40. So then this bottom part would be 40, 60, and then I'm gonna just say N for null. And then this would be 50, 70, and then it would check 60s left before moving on to the right. So we check this guy. These two both have null because the last one in the trees, in the tree. This doesn't have anything to swap with. We return check this guy to swap anything. We return there's nothing here to swap. Um, and then we return back to 60. Since we already swapped 60, we return back to 40. Then we would swap um, 40 and 20 together. So uh, so the final thing after swapping it would look like this. Oh, I don't think I got space. And 35 checks 20, checks the side of um, uh, 30's left first, which is a 20, swaps 20 first. There's nothing here, so it returns back to here. Checks the right side. Um, oh, sorry, it would be like this 40, 20, 60, no, 70, 50. So as you can see, this is our original one. And then this would be our swapped one. And as you can see, they're exactly the same, but inverted, same order and everything. Um, yeah, so that's what this is, this um recursive um invert function is doing. So let's print this out. Um, See out inverted tree. Tree dot print not in order, print tree, and then std see out um see out printing in order, tree dot print, sorry, print in order. Okay, now if we run this, here is the original tree with and 5 is the left, 30 is the right, uh 20 the left of 30, 40 the right of 30, um and so on and so forth. And here we're printing in order. So from least to greatest. Now once we invert it, um uh-oh, shoot, it didn't invert. Why is that? Silly me. Sorry, I didn't even invert it. That's why it's not inverted. Tree dot invert, not insert, invert. Um, that's why it didn't invert it here. I'm being silly. Here we go. Um, so as you can see here, here's the original tree. Um, and it's printing in order 5, 10, 20, 30, 40, 50, 60, 70. Now this is the inverted tree. And it's as you can see, this is the right node, this is the left node. Now 30 is the right node, 5 is the left node, and it still remains with the null. So it's swapping them, and yep, it's printing them out. And then as you can see right here, once we invert it, it now prints. It's still printing from the left first, leftmost first, leftmost first. But in this case, the leftmost, and this one would be 5, leftmost, and this one would be 70 down here. So yeah, hopefully y'all understood this. Yeah, thank y'all for watching.